Okay, guys. We're doing the same thing today. But things will feel a little bit more difficult because we don't recognize the radian measures as well as we do degree measures. But let me just run through the last few problems that you guys had. Okay. So let's see, page 14. We got through 7, 8, and 9. Those were the last few that you guys did as a for classwork. Let me run through those again just as a reminder of the steps, and then we're going to adapt these steps for radian measures. So for 7, we talked about how we enter this in the calculator, make sure we're in degree mode, right? And sine of theta is the same thing as saying arc sine, the same thing as saying arc sine of theta equals 0.6691. You get theta is 42 degrees. Positive sine value. You know that ultimately you're looking for degree measures in the first and second quadrant. Now 42 degrees, we already know that is a reference angle. We recognize that as an angle that is an acute angle between 0 and 90. And so we know that 42 degrees is one of our answers because it's in the correct quadrant that we're looking for. Okay. We also know to look in the second quadrant, we want to find something that's related to 42 degrees in the second quadrant. And the way we do that is we find the reference angle. So we do 180 minus 42, and that gives us 138. Okay, so whenever we want to find something related to our reference angle, we always add or subtract 180 or 360 from the fourth quadrant or from the to get to the fourth quadrant, or add or subtract 180 to get to the second or third quadrant. Okay. Number 8, inverse cosine of negative 0.9511. Enter this in the calculator, we get 162 degrees. Now this feels a little bit strange because that's not a reference angle, but we know that we want cosine to be negative, so we want it to be in the second and third quadrant. And 162, we already recognize that to be a second quadrant angle, so we can just check that off as one of our answer choices, okay? Or one of our degree measures. But we want to find a third quadrant as well, 162. We want to find something related to 162. So to do that, we subtract 180 with 162, and we get 18 degrees. And if we have 18 degrees, we can use that to help us get to our third quadrant measure, which we also want. So 180 plus 18 is 198. So we get 162 and 198. Okay, number 9, inverse tangent of negative 0.629. Enter this in the calculator, we get negative 32 degrees. Now, negative degree measure is not what we want between 0 and 360, but we know that if we take away that negative, we're staring at the reference angle. So we know 32 degrees is our reference angle. ASTC, we want tangent to be negative, so second and fourth quadrant. So I can just add and subtract 32 from 360 and from 180 to get our second and fourth quadrant, 148, 328, second and fourth quadrant degree measures. Okay. So the reason why we want to do degrees first before we did radians is because we automatically know what first quadrant is, right? We know first quadrant is between 0 and 90. We know second quadrant is between 90 and 180. We know third quadrant is between 180 and 270. And then fourth quadrant between 270 and 360. And we don't have a lot of trouble deciding where the angles are. Okay? And we also know reference angle is between 0 and 90. But imagine this for radians, we're going to be dealing with decimals that seem a lot more abstract. Okay, and that's what we're going to be working with today. Today, instead of going from 0 to 360, we're going to be dealing in terms of pi. Right? So first quadrant is going to be from 0 to pi over 2. And pi over 2 is going to be 1.57. Okay? Think of pi as around 3. So 3 over 2 is 1.5. So that makes sense, around 1.5. Okay? So any decimal value between 0 and 1.7 is going to be, quote unquote, your reference angle. Okay. Now you will get a calculator on your quiz on Friday. So if you forget these decimal values, you can just enter them in your calculator. Okay. Pi between 1.57 and 3.14 is going to be a value that's in the second quadrant. Okay. Between 3.14 and 4.71, 4.71 is the decimal value of 3 pi over 2. That's going to be in the third quadrant. And then between 4.71 and 6.28, that's going to be fourth quadrant. Okay, so same process. It's just that we're not going to recognize these measures as easily because they're radians instead of degrees. But I'll keep referring back to this sheet as we work through today's problems. Okay. All right, let's go to page 15. And let's just jump directly into these problems here. Okay, so page 15, example A. Okay, now we're using a calculator between 0 and 2 pi. Make sure that you're in radian mode. So you're going to have to go to your calculator and switch over your mode to radian. Okay, page 15 in your packet. We want to find out where sine of theta is equal to 0.2847. In other words, what is the radian measure that allows sine of theta to be 0.2847? Okay, so enter that into your calculator. And what do you get? Yeah, go ahead. Let me see.
Inverse sine, right?
Yeah, inverse sine.
Silly.
What mode are you in? Are you in radian or degree? Okay.
0.288.
You got 0.288. Okay, all right. So we know theta is
289 around up to
0.289. Okay. Now this we don't recognize, right? Because it just doesn't feel natural like degrees does. But let's look at what we're dealing with here. 0.289, is that in which quadrant is that in? 1. Okay, so that's good. That means this is the reference angle then. Okay, this is the reference angle. Okay, which quadrant do we want to be in based off of this decimal here? First and second, good. So 0.289 is one of the radian measures. It's already there. Again, it doesn't feel as natural as, say, 16 degrees, but this is what we're going to have to work with. Okay. So we know that 0.289 is our reference angle. So that's how we're going to get to our first and second quadrant. We already have 0.289, which is good. And before, we would subtract from 180 to get to our second quadrant value. Now we're going to subtract from what?
3.4.
Good, 3.14. So it's the same process. It just feels more difficult because you're dealing with these decimals that you're not as familiar with.
You need to memorize those, right? You need to memorize those, right?
Well, you'll have a calculator. So as long as you know 0, pi over 2, pi, and 3 pi over 2, you can enter that in the calculator and get those decimals.
Oh.
Yeah. So you should have that memorized already because you're in a circle. But you don't have to memorize these decimals because you will have your calculator. Okay, so what's 3.14 minus this reference angle here? Yeah, 2.853. So it feels weird because normally we would prefer to say 16 degrees and, you know, 170 or 168 degrees, right? But we have to use these decimal values because we're now in radian mode. Okay, sorry, you're right, 2.851, my bad. But if you understand the process from yesterday, you're repeating the same process just with radians, yes.
Should we plug in like the full numbers for the calculator? Or-
I would just say 3 decimal places.
Okay.
Yeah, 3 decimal places, that's good enough. Okay, any questions so far? Okay, part B. Okay, inverse cosine 0.7538. In other words, cosine of theta is equal to 0.7538. We want to solve for theta. Make sure you're in radian mode. What's theta equal to? .717, okay? All right, let's look at our, just so we have some bearing here. Which quadrant is 0.717 in? First quadrant, good. So that's a reference angle. Okay, so anything that's a first quadrant, that's good. That's a reference angle. So let's have our bearings here. Which quadrant do we want to be in?
1 and 4.
Good, 1 and 4. Now you already have first quadrant, so you can box that off. But we want to make sure we find something appropriate in the fourth quadrant. So we have to subtract from what? Yeah, 2 pi or 6.28. Yeah. Just like with degrees, you would subtract from 360 in the fourth quadrant, but now you can subtract from 2 pi or 6.28. No, no, you're right. Yeah, don't put any degree notation. Yeah, just leave it as 0.717. You guys get 5.566. How off are you? That's fine. Yeah, you know what I did? I entered 2 pi instead of 6.28. So I would say that I think, okay, the reason why I have 6.28 here is so that you can have an idea which quadrant you're in. But when we use our calculator, I think it's best if we use if we subtract from either pi or 2 pi. That way we can make the calculator give us the most accurate form. But if you're off, I'm not too worried about that. Okay, but let's take advantage of the calculator and get as much accuracy as we can. But I'm using these decimals there so we can have an idea which quadrant we're in. Okay, good. Any questions with that? Okay, part C. Inverse tangent. Okay, into your calculator it goes.
Negative 1.317.
Okay, negative 1.317. Okay, now that negative is putting it in the fourth quadrant, but if we take that negative away, is that still going to be a first quadrant value? Is that still going to be a reference angle? Yes, because it's less than 1.57, right? So it's between 0 and 1.57. That's safe. That's a reference angle. We can just ignore the negative and understand that the positive 1.317 is our reference angle. Okay, but we want tangent that's negative, right? So which quadrant do we want to be in?
Second, 4.
second and fourth. Yep, good, second and fourth. So we'll just take that 1.317. Understand those are reference angles. We have to subtract from our x-axis, right? The reason why is tangent of theta is equal to negative 3.8. So tangent is going to be negative in the second and fourth quadrant. Right, ASTC, yeah, yes.
Like 0 to 5, why don't you have to like subtract it or like add 2 pi to it until it's positive instead of making it?
You're right, we could. It's like negative 30 degrees. If I do negative 30 degrees plus 360, I get 30 degrees. So same thing here. If something's already like negative decimal value, that's already a reference angle. If I add 2 pi, I will still get 1.317. Yeah. Okay, so I'm going to subtract from 2 pi to get my fourth quadrant. I'm going to subtract from pi to get my second quadrant. Okay. So what do you get for your fourth quadrant value? Okay, 4.96. Okay. And what you get for your second quadrant? I subtracted from pi, so I think I got 1.824. Let me see. Now it will feel a lot cleaner if we could see this as like, 170 degrees and 340 degrees, right? But we just have to kind of get used to these decimal values. 4.966, that's safely between 4.71 and 6.28. So we know that's in the fourth quadrant. And then 1.824, that's between 1.57 and 3.14. So that's safely in the second quadrant. We have our two theta values that we are looking for. Yes.
Why is it negative 3.17?
Because the negative 1.317 is a value that's outside of my interval. We want an interval between 0 and 2 pi. So
Okay.
if you really wanted to, you could do negative 317, add 2 pi to it. But it doesn't return us. Let's see. See here. Is it just the second quadrant? Let me get back to you on that. Let's continue on and then Sorry, what you got? Right. I think your question was, why is that negative 1.317 not turned into 1.317? If I, sorry, if I add 2 pi to it. Yeah, let me answer that question. I'll find out. All right, guys. Let's try number 1. Okay, try number 1. Okay, which quadrant do we want to be in? First and fourth, right? So 0.1693 is safely in the first quadrant. Also your reference angle. So 0.1693 is one of your answers. Subtract from 2 pi will get you your fourth quadrant. Yeah.
Oh, never mind, sure. I missed that.
I see. Okay, yeah.
You look around and like 1,000 places to live there. 10,000.
That's fine. Yeah, I won't be picky once you get past this value, either the thousands or 3 or 4 decimal places. Yeah. Okay, all we're doing is just page 15. So as you guys go through, I'll just continue showing you the answer so you can check your work. Tricky thing is when cosine is negative, because you have to recognize that's in the second quadrant. So we'll go over that. That's number 6. Number 6, it's just like inverse cosine with negative. We gotta just kind of work backwards a little bit to get to where we want to be. So I think inverse cosine negative are the hardest ones. How'd you get the 4.6 instead? Oh, I know my reference angle is 1.4523, right? And 1.5213. So third quadrant, I have to add pi to it. So pi plus 1.5 gives me 4.6. I know we're used to adding, subtracting from 360 to 180. We should now replace 180 with pi and replace 360 with 2 pi. Oh, no, we never want to subtract from 3 pi over 2. We always want to subtract from either pi or 2 pi. Yeah, so never use your y-axis to find any of the reference angles. Yeah. Oh, why not do 3.14 minus 1.5? Is that what you're asking?
Yeah.
Because we're talking about tangents. We want a positive value for tangent. The tangent's positive in the first and third quadrants. ASTC. The third quadrant is 180 plus the reference angle. In other words, pi plus 1.5.
And then the second quadrant, you subtract.
You subtract pi minus 1.5.
Which ones do you add, the third and the fourth, or just like the third and?
So the first, you don't do anything. The second and third, you subtract or add from pi. If it's radians, then this is degrees, you subtract or add from 180 or pi. But if it's in the fourth quadrant, you subtract from 2 pi.
Okay.
So you're only playing with 180 and 360 or pi and 2 pi. Like if you're in the first quadrant, you leave it alone, it's already there. Okay, are we okay with number 2? On page 15. Same thing as yesterday, just instead of degrees, it's radians. So instead of adding and subtracting from 180 and 360, we're doing adding subtract pi and 2 pi. And then your calculator needs to be in radian mode. Okay, number 3.818 is safely between 0 and 1.57. That's a reference angle. Want first and second quadrants?
Oh, why would you switch it to the inverse of it? You just, every time it's positive, you just always switch it to them. Like sine and negative one.
Sorry. For all these problems, we'll do inverse.
Oh,
Yeah, every one of them you'll do inverse.
You never put it in positive.
Oh, yeah, this negative is not negative positive, it's just notation for inverse. So you're not gonna have to put any negatives in there per se.
It's just always.
That's right, yeah, it's always, yeah, that's just notation for inverse. Arctangent, if they ever return you a negative value, just convert it to a positive value and just treat that as your reference angle. And then go about finding what you want to find in their quadrant that you want to look for. Okay, so far, 1 through 4. Okay. Yeah, whenever you get a negative value, just remove the negative and just understand that's a positive version of it is your reference angle. And then use that to help you find the quadrant that you're looking for. Yep. Yeah, number 6, I'll go over step by step because it just inverse cosine negative, it just feels off from the other ones. Okay, are we okay up to 5? Give you guys another minute. So I can go through 6 with you. Okay, you guys okay with up to 5? All right, so let me go over number 6. Number 6 says cosine of theta is equal to negative 0.4018. We do inverse cosine, we find theta. Okay, what do you get for theta? Okay, 1.984. Okay. Now, let's double check that. Which quadrant is that in? Second quadrant. Okay, so this is not the reference angle. This is second quadrant value here. So let's draw our coordinate plane here. It's like as if a degree measure that's giving back to us is 130 degrees, right? We know it's in the second quadrant. Okay. Now, where do we want our answers to be in? Second and third. Well, that second quadrant is one of our answers, so that's good, right? But we have to find second and third. But to do that, we need the reference angle so we know how far to go past pi. So how can I find this reference angle that can help me out with my third quadrant?
Try to figure out 1/4.
Good, subtract from pi, yeah. So this feels a little bit different because normally you're given the reference angle and you're working towards your angle. Here, I gotta work backwards a bit, get that reference angle so I can use that to help me with my third quadrant. Okay, what you guys get for your reference angle? Good. Okay, so now it feels more familiar. Now we know what to do. Add 1.158 to pi. There's your third quadrant answer that you're looking for. Yes.
I know when you have a reference angle versus when you have one of the measures of theta.
Good. So the way that we know is we have to understand that a reference angle is between 0 and 90 degrees. That feels easy to recognize from a degree perspective, but from a reference angle, it's between 0 and pi over 2, and the decimal version of pi over 2 is 1.57. Okay. Now that feels hard to memorize, but you will get your calculator on Friday, so you can just always punch those values in to get your decimal value. Yeah, so between 0 and 1.57, you know that is a reference angle. All right, go ahead and finish off 7 through 9. I'll come around and check you off, but I'll also put up the answer so that you guys can um check your work.
The hardest to get is like,
Yeah, this is hard as gets. This, I think this is the hardest one with the inverse cosine.
so inverse tangent would be as bad.
Yeah, inverse tangent is easy because what, if you get a negative number, you know that is your reference angle. Remove the negative and then just figure out which quadrant you're in. Yeah. It's just the inverse cosine negative that feels a little different. Guys, I wanted to get a little bit ahead so that tomorrow we can do a full quiz review. The packet that you picked up, there's 2 quiz reviews in there. I'll do the first quiz review in class tomorrow. The second quiz review you can use as your own practice, but I also have a morning help session Friday to go over that second quiz review. Friday is going to be an early release, but it's actually a little bit more time than what I expected. I think we have 40 minutes. That should be plenty of time to do 5 problems, so we shouldn't have any issues.
Yeah. What is that?
love that.
Well, what? Yeah. What? Not my boyfriend.
We like that, we like that. Oh, yeah, okay, yeah. You're right. You do it, you're 100%. That's great. You high minus. You know, like some questions we find that my greatest one, I don't like the guy, I'm gonna have to find what the angle is. Like, so when they know when they have to find that angle, and then you have to just have that.
Where's?
So,
Draw it.
Whoa, me. That's fine. That's no where I want it. I think actually 10 minutes ago.
That's.
It's so weird.
He goes, no, we don't. I'm like, yeah, wait, yeah. No, I'm saying, I think 11 hours. Just don't tell. Say no, I'll talk to this guy forever.
Let's get going, because we're talking.
Someone's randomly asked me if there was a shooting at my school right now.
First sign.
Wait, what was that girl? What's going on? What's going on? I don't know what's going on. I like randomly added this.
Here's number 9.
That's what I'm asking. I'm like, did you hear something that I haven't heard?
What?
Dog. It's not just him, it's other people talking about. Other people are asking.
Is there?
Yeah, there's another question. It's like asking like, so are you good?
When do you know like when to add it to pi and when to subtract?
No, it's
Depends on which quadrant you want to be in. If you want to be in the second quadrant, you want to subtract